Good morning, students. Coming back to CAD CAM. Today's topic is output device, and its subtopic is graphic display devices. And graphic display devices, we have done about CRT, DBST, and raster and random scans. Now we are on to raster refresh display. Raster display, the display screen area is divided horizontally and vertically into a matrix of small elements called picture elements called as pixels. You all may have heard about this uh, that your mobile is that much megapixel and all that, right? So pixel is the smallest addressable area on the screen. Number of if the number of pixels on a particular screen is more, that means the divisible area, the small divisible area is very small. Then that means that particular very small area is being illuminated when this discharge is being attached around that screen, right? Pixel is the smallest addressable area on the screen. As the pixels are increasing, when you increase the pixels, that means the smallest addressable area is increasing. That means it is decreasing by very small area. So with the decreasing the small pixels, the clarity of the image will get increased. As the number of pixels will increase, that means then if you increase this matrix from, say it is 10 in the left and 10 10 the vertical side and 10 the horizontal side. If you increase this matrix from, instead of 10 to 10, instead of we increase the number to 20 to 20, the same area, then there will be another line in between, say, then the pixel area or that square area will become very small. That means that particular area will illuminate when the electric discharge is applied across that particular display. So as the pixel increases, the clarity of the image increases. The typical resolution of a raster display is 1280 into 1204. That is from vertical to horizontal. That this matrix shows that in horizontal side you will have 1280 rows, and vertical side you will have 1204 rows of this columns, right? Each row defines a scan line. When you're moving, each row will show you a scan line. That means we have done it in the last, that this is the scan line. Each row represents a scan line. That this according to this, each row will illuminate, or that the gun will move from left to right in each row to eliminate a complete image. It is just an advancement of raster display, raster refresh display. Pixels are controlled by electron beam. Again, electrons are being hit. Again, CRT tube is there. Then it generates electron. Then it accelerates that. There is acceleration of that. Then it is focused, and then it is deflected at particular point to illuminate that particular point where the image has to be generated. So electrons are being emitted, and that are strike on that phosphor coated screen. The beam always starts its sweep from top left hand corner regardless of what has been drawn. Top left corner. This is the top left corner. The image will start from this end, and it will move like this, then it will move like this, and this, so on. It will start from this, whatever the image may be. It will always start from this top left corner. Top left corner is this one. Finishes on the horizontal to the right and moves down on the row of the pixel and returns so again from left to right. It then refreshes by commencing the whole procedure again from the top left corner. It, it is repeated again and again to generate an image. Each refresh operation takes about 0.02 seconds. So that means this movement of this gun from top left corner to the bottom will take in 0.02 seconds. That is not observable. Images are displayed by converting geometric information into pixel value. Any image that is to be generated, any of the image, if you are you are able to see me on your mobile phones or laptop. So image is being generated, that is the conversion of image into geometric information or into pixel value. That is pixel value. The creation of raster format from geometric information is known as rasterization. You may be asked, what is rasterization? Rasterization is uh, the image that you are able to see on your screen. It is in the form of pixel or geometric information. But uh, what we draw on screen with the help of some say lines and circles, that is a raster format. The conversion of raster format to geometric information is called as rasterization. Sometimes it is asked in the final exams also, and some of the MCQs are also based on this. Graphic display devices. Then after this, there is a correct graphic display devices. के अंदर we are having colored raster display. When you want to see, uh, up to this we have just discussed about black and white images, right? If you want to see a colored image uh, of a particular say thing, then there should be three guns, one for each primary color. It is not like that. Okay, we should have uh, a, a gun for pink color, one gun for red color, one for orange color, and so on. Oh, each gun for each color. Not like that. No, it is not like that. We need to have only three guns. It generates only three primary colors. Just mixing these colors will produce different colors, right? But there are three electron guns, one for each primary color: red, blue, and green. Only three primary colors are there: red, blue, and green. That is required to generate different colors. Then three electron beams are deflected and focused at a group into the shadow mask, which contains a series of holes aligned with the phosphor dot pattern. So it is so arranged that there should be a three guns. You can see the diagram also. It is like this. This is the three guns we are having. Red, R stands for red, B stands for blue, and for this green. These three are primary colors. When they generate electrons, and it is passed through some shadow mask to focus it to a particular point to generate that particular image is called as this. This is how an image is generated in colorful pattern. This is the shadow mask that is being used in our CRT, and this is also shadow mask that is being. The three electron beams are deflected and focused at a group onto the shadow mask, which contains series of holes aligned with the phosphor dot pattern. So when it passed through this shadow mask, that image is being generated on the phosphor coated screen. When the three beams pass through a hole in the shadow mask, they activate a dot triangle, which appears as a small color spot on the screen. Basically, the three guns that are producing some images, one for red, one for blue, and one for green. When they combine, the combining process is being done by the shadow mask to generate that particular color that is required. Suppose we talk about that sky blue color. So we have having a blue color just to mix. How much mixing is to be done of these three color to produce that sky blue color? Then it is being done with the help of shadow mask. By varying the strength of electron beam for each individual primary color, different shades can be obtained. You can obtain different shades or by varying the electron beam strength of the electron beam that is being generated from red, blue, and green. So two different ways to generate an image. First one is mixing of different colors that can be done with the help of shadow mask, and you can increase or decrease the intensity of particular color. You want a dark red color, maroon color, you want to reach to maroon color. The intensity of particular electron beam can be increased or decreased to produce that particular image. So this is the combined effect to produce a colorful image. It is produced only because of red, blue, and green electron beams that generates red color, blue color, and green color. And shadow mask mask is there that mixes all these colors to produce the desired color that is required. So this is how a shadow mask is look like in our books, but in actual it look like this. That is existing in our laptops or CRT screens.
No, sir.
So next part is liquid crystal displays, LCDs. Initially, we are onto CRT screens that we want to. When you have that TV, big TVs that is extended towards behind also. Then the next advancement was LCD that we have seen say 5 years back. Now we are onto LEDs, light emitting diodes. But before this, we used to see LCDs, liquid crystal displays. It is very thin as compared to CRT. CRTs are very bulky and it is extended towards behind to some extent, say 1 feet around. But LCDs are very thin and LEDs are further very much thin as compared to LCD. LCD uses liquid crystal to produce visible image, right? Liquid crystal, what is crystal? Crystals are the solidification of some object. When you form solidify something, crystals are formed. You can uh, melt sugar, right? Then by adding some water and heating it. Once you keep it for some while, it will get crystallized. So that is a crystallization of something. So LCD is liquid crystal, not a solid crystal. It is a liquid crystal. You can call it. It can be called as liquid also. It can be called as crystals also. So LCD is liquid crystal to produce visible image. They have a dual property of liquid as well as solid. Liquid crystal. We are talking about liquids and crystals also. So they have a property of liquids also and solids also. They can keep themselves aligned and can move as a liquid also. So they are crystalline in form. They can move also. They can align themselves like a solid also. So this is the principle. This is how image is generated with the help of a liquid crystal display. The principle behind LCD is that an array of liquid crystals becomes opaque when electric field is applied across. When you attach electric field around across some liquid crystals, it aligns themselves and it becomes opaque when electric field is applied across it, and it generates an image of that. Hence, can generate image by aligning crystal as desired. So they align themselves and they generate image. They glow when electric field is applied, and they glow also. They align themselves and they become opaque. Initially, just like a sugar crystals, they are clear crystals. But once you applied a electric field around it, then it becomes opaque. That means you cannot see beyond what is beyond that once that electric field is applied, and it starts glowing, and they align themselves and produces light. Liquid crystal displays are super thin technology display screens that are generally used in laptops, computer screens, TVs, cell phones, and portable video games. So this is the technology that was used earlier for production of some image. So they are super thin technology. They are very thin in nature. As I have told you earlier also that when you earlier you when you were using some TVs when you are at the young age, say 10 years back, you were able to see TVs that are extended towards 1 feet at the back end. Then that type of particular screens are called CRTs, and they are having picture tube also. But then after that, we have wall hanging LCDs. They are very thin in nature and they are very light in weight also. Then after that, we are having this LEDs now, right now. So liquid crystal displays are very thin in nature, right? Now just see uh, image that is there, how LCD works, what are the different components that are there in LCD. There is a mirror at the rear end. If you want to produce image of say 6, if you have come across to see some LCD displays, you can see that at the rear end of it is a mirror image. You may see that it looks like a steel, but it is actually a mirror. Then after that, it is a glass. This is the glass filter and polarized film, polarizing film. Polarizing is just filtering that image particularly. Then glass filter is there. Again, it is a filter to filter the image. Then negative electrode. Then liquid crystal. This is the liquid crystal that is being applied with electric field to produce an image, right? Then positive electrode is there. Then glass filters, again there is a glass filter. And finally, the display images on this glass, the cover glass. You can see the image on this cover glass. So these are the few components of LCD. Starting from the mirror, this is the polarizing film that somewhat it is a filtering process. Then again, there is another filtering glass that filters uh, the reflected image that is from the mirror. Then there is this negative electrode. Then we have liquid crystals. When electric field is applied across these two, and negative electrode and liquid crystal layer, then an image is generated. When this image is generated, that is being again filtered with the help of some glass. Then polarizing film is there, and ultimately a screen produces that image. So this is how LCD works. You need not to go deep inside that, because what is polarization, what is this negative electrode, liquid crystal, you need not to go deep inside that. Just basic how it works. It is important up to that only. Now we are into the next topic, that is graphic standards. Now graphic standards, what is the need of graphic standard? What is graphic standard and what is the need of graphic standard? That is important. In earlier times, say America, Canada, Australia, they are separately working on say CAD software, designing software. They separately were working on. America was working on some other software. Canada was working on different software. Then Switzerland is working on different software. Different countries were working on different softwares. So graphic standards, what graphic standard gives you, it gives you a portability. The image that is being generated in say America can be transported in Canada, can be transferred to India. Graphic standards maintain the standardization of all the softwares, right? It can be transferred from that place to this place. And portability of images, right? Image generated in say at Russia can be transported to India and different countries, like that. The software being used over here also. So there is a need of some standardization of software, how it is applicable, how it works, and so on. So what is the need of graphic standards? First one, this is the standardization of process of standardization, the graphic standards. Graphic standards क्या? What is graphic standard? When you talk about some generation of images and all that, you need to standardize the process, the whole process of generating the image. Graphics means whatever we draw or line, circle, and all these commands on the screen, that can be transported from one place to another. That is the need of that time. So then that time they started working on standardization of these, so that all the picture can be transported from one to another. Now let us read this need for the graphic standards. Application program portability. This avoids hardware dependence of the program. For example, is when a program is written in, if a program is written in originally for DVST display, it can be transported on raster display with minimum effort. So Again, as I have told you earlier, also, it gives flexibility from one software to another software. That can be if you want to work on some DVST, initially you are working on DVST, and that can be transported on raster display also. Image that is being generated for CVTs can be transferred to LCDs, and that can be transported to this LEDs also, right? Now, picture data portability. Picture data portability is data image that is stored. I suppose I make image of some screw jack or some. You all may have learned about this uh, pipe joints, right? Knuckle joint and all that. I have made a knuckle joint. I did. Then I want to be sent to all of you. I can send that in a mail. Then picture data is you can open it in the laptop. So description and storage of picture should be independent of different graphic devices. That can be opened in your mobile phones and all that. Right? Text portability. Text portability is when you write something I have made a knuckle joint, and then I have written made by Amandeep Singh and all that. I have given specification of this, like this is the left hand side part and right hand side part, whatever the parts are, and given the description of all these parts also. That can be read by you also. For text portability also should be there. Object database portability. Sometimes the CAD database is to be shipped to outside vendors to manufacture the product. Generally, what happens actually? Suppose I want if someone is manufacturing, if some car is being manufactured, you will design a headlight of the car. Then when you have designed that headlight of the car, you cannot manufacture that light out. That is being manufactured by some outside vendors. So that drawing has to be sent to some vendors also. So that should be that portability should be there. That whatever you have made database that can be transported to some other manufacturer also. I hope it is. Then graphic standards. Some of the graphic standards are on your screen. Types of graphic standards. GKS, Graphical Kernel System. PHIGS, Programmers Hierarchical Interface for Graphics. IGES, Initial Graphics Exchange Specifications. DXF, Drawing Exchange Format. STEP, STEP, Standard for the Exchange of Product Model Data. DMIS, Dimensional Measurement Interface Specification. VDI, Virtual Device Interface. VDM, Virtual Device Metafile. NAPLPS, North American Presentation Level Protocol Syntax. So some of them are for the exchange of drawing. Some of them are for the exchange of dimensioning. Some of them are for the display of display exchange. So some format came according to the need at that time. So let us move to the next slide. With graphic standards in programming, graphic database. Graphics database. If you talk about database, so there are 4 standards for that: DXF, IGES, STEP, and SET. They are based on change of graphics database. That graphics database that is in your laptop or computer that can be transferred to some other place with the help of DXF, IGES, STEP, and SET. And if you want to shift the application program, right? Application program from one laptop or one device to another device, then you use these standardization processes that like GKS, PHIGS, and core. Graphic functions. Uh, Graphic functions are application programs are like AutoCAD and CATIA, ProE, and all that. They comes under application programs. Databases, when you store something, when you save a drawing in your laptop or computer, that can be transferred with the help of DXF, IGS, STEP, and all that. Application program like AutoCAD, ProE, and different software, CATIA, StatPro, and all that. That can be transferred from one place to another. Then we have graphics functions. Like You can have check for the interference, you can check for the assembling, you can check for the wireframe and surface modeling and solid modeling. That type of functions is standardized with the help of VDI, VDM, and NAPLS, all that. This is the now device driver and devices to the drive device. So these are the some functions that are being standardized with the help of these standards. So this is all about exchange between systems. You can exchange a CAD A, CAD B, CAD C, and CAD D. All these standardization, I have just drawn this diagram to show you that one diagram that can be transferred to other and one other to third to fourth and all that. They can mutually exchange also. Is there any problem in sound? There is some voice from outside. If you have some problem regarding sound, then do inform me.
Yes, sir. कुछ
There is some disturbance.
यार आपका सर वो क्या बोलते हैं, आप जो ब्रीथिंग कर रहे हो उसका भी साउंड आ रहा है।
अच्छा, अदरवाइज नहीं आ रहा है कोई बात?
नहीं सर।
चलो कोई बात, वो मैं थोड़ा दूर कर लेता हूँ, फिर नहीं आएगा। Right? So CAD A, CAD B, CAD C, and CAD D is there. You can exchange different processes along each of the computers. Right? Now, graphic kernel system. The first one that I have shown you in this types of graphic standards. GKS, PHI, GS, IGS, GP, DXF. Then we are to discuss all these fine step by step. In graphics kernel system, it is a device independent and host independent and application independent. This graphic standard makes a particular drawing device independent, host independent, and application independent. With this system can work with all types of input and output devices. You can work with different input and different output devices. Like you can work with printers, you can work with monitors, you can work with say monitors like CVTs, then DVST, and raster display, a number of displays methods. It supports both 2D and 3D drawings. You can see and draw 2D drawings, and that can be transported from one place to another. It interfaces the application program with the graphics support package. Graphics support packages are like input and output devices. Application programs are like AutoCAD, FATCAD, and Creo. The interface is there. All text annotations are written and stored in a natural language. Natural language can be read in different softwares also. To control all types of graphic devices such as plotters, display devices, and persistent manner. So it is basic graphic kernel system is the best graphic standard. It standardizes all the processes. In fact, the next the standardization came with the name programmers hierarchical interface and interactive graphic standards system. It is used for high functional system for its ability to handle dynamic graphic changes, supporting segmentation of graphic display. Now, what is this? When you dynamically change something, that so suppose there are 5 computers, they are under networking. So one is working on one part, one is working on different part, third one is working on different part. Suppose one is working on the suspension system, other one is working on steering system, the third one is working on lighting system and all that, right? This designing software, right? So this is segmentation of different parts. So 5 people are working together in different their PCs, workstations. Then this dynamic changes. One is doing some changes that can be visible to all of them. So this is dynamic changes. And segmentation is when you talk about same drawing and different segments are there, and 3 different or 4 or 5 people are working on different segments of the same drawing. That can be possible in this programmer hierarchical interactive graphics system. It defines a set of device independent logic concepts. So it gives you independent logic concepts. It involves 6 basic logic concepts, that is structure, network, and manipulation. That as I have told you, networking should be there, and manipulation is possible. Logical input devices. Then we have this logical input devices, search and inquiry, structural, transversal, and display, and graphics output and viewing pipeline. These are 6 basic logical concepts that are there in programmable, programmers hierarchical interactive graphics system. Then initial graphic exchange specification was approved in 1981 as ANSI standard. It enables an exchange of model databases among CAD campus. Database can be exchanged with one another only. The function at the level of object database or application database. So it works on the database and application softwares. Standard for exchange of product model data, that is STEP, was approved in 1983 as ISO standard, Indian Standard Organization. ISO stands for Indian Standard Organization. It standardized the exchange of digital product data, includes geometric shapes, topologies, tolerances, relations, attributes, assembly, and analysis. Geometric shapes, like when you talk about rectangle, sphere, triangle, and all that. Topologies, I will explain you in the coming slides what is topology and geometry. There is slight difference between geometry and topology. You are going to get it in the next coming slides. In today's lecture, say in the evening also, can be it can come in the evening lecture. But today itself, you will be very clear about geometric shapes. When I will show you the diagrammatically what is the difference between topology and a shape. Then tolerances, I think you are well aware about what is tolerance. When you want to drill a hole of say 5 mm, so there is always a tolerance of 0.01 or 0.01 mm. It can be increased by 0.01 mm. It can decrease by 0.01 mm. Then relations, attribute, assembling of different parts, analysis, and all that. So it is very important standard that is being devised by ISO, Indian Standard Organization, can be used at any stage of product development. You may have I have written that ANSI, full form of ANSI is American National Standard Institute. That is American standard. This ISO is Indian Standard Organization. Then virtual device interface. Now lies between GKS and PHIDS, and the device handler driver code. It is lowest device independent interface in graphic system. So least device independent interface is this. So this one is least lowest device independent. But the rest of all of these standards are very much independent of this graphic system. It is designed to interface plotter to GKS and PHIDS. So basically, virtual device interface is being designed to interface plotter with this GKS and PHIDS. Earlier, it may not be the same, and it is now called computer graphics interface (CGI). It is not well matched to a distributed and network environment. When you are, as I have told you earlier, that there may be 5 computers that are connected network with the help of network. They can be working on the same drawing on different segments. So this particular VDI cannot work on network environment where networking is done. Same thing can be done with the if you want to work on same drawing by 5 different people and the segmentation is there, it cannot be done with that. Virtual device metafile describes the function needed to describe a picture. Such description can be stored in or transmitted from one graphic device to another. It functions at a level just above device type. VDM is now called as computer graphics metafile. If you want to describe a picture, like you want to give some dimensioning and all that, so that this particular part is the name of that particular part is this, the name of that particular part is this. That can be done with the help of virtual device metafile at the level just above device driver, right? So this is medium. The last one is North American presentation level protocol syntax. Now we have Exchange programs, Exchange drawings, Exchange application software, and all that. After that, there should be a standardization of if you want to present something, a drawing should be presentable. So that standardization was available with the American Standard Code for Information Interchange. It explained the standardization of text and graphics in the form of sequence of bits and ASC2 codes, right? So presentation has to be improved. That was standardized with the help of American Presentation Level Protocol syntax, NAPLEPS, right? This is the graphic standards. So welcome once again. Now the second chapter of your syllabus of CAD CAM is geometric modeling. This chapter is based on different modeling techniques that is there. Geometric modeling is drawing something. You want to draw something, different techniques that are there. We are going to learn that in this chapter. What is wireframe modeling? What is surface modeling? What is solid modeling? What is body representation? And what is constructive solid geometry? Learn all these topics in this. This is a very small chapter actually. Now, geometric modeling is the representation of physical object in a on computer, allowing both interactive and automatic analysis of design and the expression of design in the form of suitable for manufacturing. Basically, it is a representation or making a drawing of anything on computer. Geometric modeling, all about that. Function of geometric modeling. There are different functions of geometric modeling. First one is design analysis. You can analysis for area and volume. Whatever you have made, suppose you make a complex drawing of your house, say, then you can calculate the area of each room, and you can even, if you constructing some 3D figures, you can calculate volume of particular cuboid and all that. Checking interference and assemblies. There are number of assemblies are there. Like if you talk about piston cylinder arrangement, if you want to draw that, the piston has to be assembled in the cylinder. You can check for the interference, right? Whether that piston will move inside that cylinder or not. Analysis of tolerance built up in the assembly. Tolerance is given, right? If you give some dimension, say 45, that tolerance is 0.01 or 0.02, less than or greater than that. Analysis of kinematic and machine. You can check for the kinematics of machines and robots that are existing in that particular system. Automatic mesh generation for FEA. There is a chapter in your syllabus that finite element analysis. In that, there is a requirement of generation of mesh, right? In which you are to calculate stresses at particular, as you have seen that pixels. Similarly, a particular, suppose you draw something, right? You draw this piston cylinder arrangement on your laptop or screen, in your personal computers, PCs. Then you want to check for the analysis of stress analysis. How to be done is with the help of this FEA, finite element analysis. That particular product on which you want to check for the stresses, you apply FEA. FEA is dividing that whole surface into minute number of small areas. Then you check stresses on each small area. This is called FEA. Now, mesh generation is dividing that area into very small parts. We will be doing that chapter FEA. We will be more clear. We will get more clear when we reach over there. Then drafting Then we are to drafting is drawing something, automatic planner, cross sectioning, hidden lines and surface removals, automatic production of shaded images, automatic dimensioning, automatic creation of exploded views for the technical illustrations. So basically, whatever a drawing needs, that is to be done, that comes under drafting. Then manufacturing, then you need to classify the parts. Suppose there are a number of parts are there in particular. You manufacture a car, say there are a number of parts in a car. Say cam, valve, piston, connecting rod, and all that. There are a number of parts are there. So these parts should be classified. That you cannot call each time that I want that valve, input valve and output valve. They are classified with some number. So classification should be done with the help of these computers in this geometric modeling. Process planning, then which process to be done earlier and which process to be done afterwards. Process planning should be done. Numerical control data generation and verification. Then you can numerically control the data and verification of these. Suppose you have given some parts or some names, you can verify that whether that initially exists or not, and verifying that. For robot program generation, suppose you have a welding robot, then you need to generate the program for that particular robot. Production engineering, you all have learned about this BOM, bill of material and machine drawing, material requirements, manufacturing resource requirements, what material and how much material is required for particular production, manufacturing resource requirements like human sources and all that. Scheduling, scheduling is when you schedule something with how much production is required, say for one day, and what how much production is required for 1 month, and so on. That is scheduling. Scheduling is, can be also includes that per hour how much work is to be done. Inspection and quality control. So after you have completed that, then inspecting the product that is manufactured, whether dimensionally it is okay or not, then checking the quality of that product, whether that quality of that product is okay or not. So this is some of the functions of geometric modeling. If you want to ask something, you can. So next, general requirement. General requirement of a geometric modeling is the evaluation of geometric properties such as centroid, cross-sectional area, surface area, and so on. General requirement of geometric modeling is you should be able to calculate the centroid, cross-sectional area, surface area, and volume. Evaluation of mass properties such as mass, density, and inertia. Particular geometric software should be able to calculate the mass, density, and inertia of that particular object. Finite element analysis and optimization. Finite element analysis (FEA) is again subdividing that particular part that you have that you are going to manufacture. The design of that part should be that particular CAD software should be capable of for FEA analysis, and then if that is prone to some strain or say some defect, you need to optimize that. That means you need to change the design. Again, go for a FEA. If still that exists, then you need to change the material or something, then so on, till that particular desired object is made. Volume visualization, whatever the volume is, you can visualize that. Animation of the graphics, you can animate that graphics. Like if you made some piston and cylinder arrangement, you can animate that to check the interference of that. Automatic assembly, made some different parts of the piston cylinder arrangement that can be assembled. Tolerance analysis for process planning, assembly operation. You can you can do analysis on for tolerances, then process planning, assembly operations, part inspection, and interchangeability manufacturing. Interchangeability is you can manufacture different parts on same system. Manufacturing comma, NC code generation. Finally, manufacture that product. Once you have made the design, you have to manufacture the product. Then code generation is the programming of that particular part. Computer aided inspection and control. Once you have made a product, then it has to be inspected for the quality and dimensional purposes, and then you have to check control that also. If there is some defect in that, you need to control the process wherever the defect is being detected. Now, as I have told you that in the coming slides, you will be seeing that topology and geometry. What is the difference between topology and geometry? They are very much similar to each other. They are related to the geometry. You can see that in first diagram, A, same geometry but different topologies. One rectangle is there, one semicircle is there. That is the geometry of that particular figure. Topology is different. That semicircle is inside in first diagram and semicircle is outside in another diagram. So it has same geometry but different topologies, right? In this case, same topology but different geometries. Topology is same. A rectangular shape, a circle is inside, Same topology is there, but geometry is different. In this case, you cannot call it a rectangle. This is a rectangle. This cannot be called as a rectangle. I hope it is clear that what is a difference between topology and geometry. They are very much similar in terms of general definition, but diagrammatically you can see that there is a lot of difference between topology and geometry. I hope you have understood this, the difference between different geometric modeling techniques. So that we are going to come across. When you are going to start with your lab work from tomorrow onwards, you will make, we are going to start with the 2D modeling, then 3D modeling, wireframe modeling, surface modeling, and solid modeling. 2D modeling is when you draw triangles, squares, circles, and all that. This comes under two-dimensional modeling. When you talk about three-dimensional modeling, we talk about wireframe modeling, and you draw something with the help of lines and all that. 3D figures with the help of lines is called wireframe modeling. When you can create some surfaces with the help of surface modeling, you have to draw analytical surfaces, freeform or curved sculptured surfaces that comes under surface modeling. When you take a complete as a solid to represent a particular figure, 3D figure, then we call it a solid modeling. Or solid modeling is further divided into three different parts, that is CSG, constructive solid geometry, boundary representation, VREP, and parametric modeling. Now starting with two-dimensional modeling, 2D modeling, it includes the construction of symmetrical spaces, plane drawing, two-dimensional views, top view, front view, and left of the object. The application of 2D models, it's limited to drafting sheet metal and manufacturing, spot welding, laser cutting, etc. The screen, the diagrams that is on your screen, they come under 2D figures, not this one. This figure and this figure and this figure, they come under 2D diagrams. And the first task that I am going to give you tomorrow is this drawing, how to draw this diagram. You need to understand this. How to draw this will be your tomorrow's task. I will tell you how to draw a circle. I will tell you how to draw lines. Then dimensioning, we will not start tomorrow. Dimensioning will not be starting from tomorrow. We will start with the lines and circles and rectangles, triangles, and all that. Right? Now, 3D wireframe modeling. As I have told you earlier also, that when you draw a 3D object, but with not surfaces, instead of surfaces, you are using lines to draw a particular 3D object, like a cuboid that you make generally in our on our board, also in your notebook, that comes into wireframe model. I will show you the wireframe models of some of the diagrams. Now you want to see this. This is a cuboid with no surfaces. You can see this. It is made with. It looks like it is made of some wire. So we call it a wireframe model. This is the sphere 3D model, but it is generated with the help of some lines and all. Again, this is, you can call it circle or cylinder also. This is our pyramid, and this is some ring that is being generated with the help of wireframe model. So this is all about wireframe model. It is developed in 1960 and referred to as stick figure or an edge representation. It is an extension of traditional method of drafting. The word wireframe is related to the fact that only one may imagine a wire that is bent. Yes. Ashri, what do you want to say? The word wireframe is related to the fact that one may imagine a wire that is bent to follow the object edges to generate a model. As I have explained you also that an image that looks like it is formed with the help of some lines or some wire, we call it a wireframe model. The model consists of entirely point, line, arc, circle, and conics and curves only. There may be no surface there. It doesn't look like a solid, but it is a model of a solid figure. In 3D wireframe models, an object is not recorded as a solid. Instead, the vertices that defines the boundary of the object or the intersection of the edges of the object boundary are recorded as collection of points and their connectivity. As I have told you again also, that it doesn't look like a solid, but actually it is a figure of a solid just by connecting some lines and figures. It requires lesser computer time and memory. When you want to save a particular 3D figure and it is in the wireframe model, it requires lesser space as compared to the solid and surface model. Can be used for simple NC tool path generation. It can be used for simple NC tool path generation. 3D wireframe modeling, wireframe model lacks visual coherence. When you look at these figures, they doesn't look like a actual solid. Though they are, we have made a solid, but actual ones who is not aware about the wireframe modeling, you cannot imagine that this particular body is this figure. And there is a confusion of some all, there are a number of lines that is visible to you. Then these lines will confuse you that whether that line is behind or in the front. You can see this cuboid. You cannot judge that this is the front view or this is the front, or this line will lie in the front or this line will lie in the front. You keep on looking at this diagram. You can see sometimes you will feel that this is in the front, and sometimes you will feel that this line is in the front, this edge is in the front. So that confusion is always there in wireframe modeling. And on wireframe modeling, you cannot use finite element analysis. You cannot apply FEA analysis process on wireframe model. That is possible only in surface modeling, or it is very difficult to remove hidden lines based upon wireframe model. Some hidden lines are there, like these lines at the rear end should be deleted, but they are not possible to delete in wireframe model. So we will not move to the next slide. We will keep up to this, and we will take another poll for today.